Take it away, Andrew.
Thank you. First slide, please. So the Carpinteria Salt Marsh is a 230-acre coastal wetland located about 45 minutes north of the city of Los Angeles. Next slide. The Thomas Fire, which started in late fall of 2017, and at the time was the largest recorded wildfire in California history, burned the foothills of the Santa Ynez Mountains immediately to the north of the salt marsh. Next slide. And most people are familiar with the Montecito debris flow, but there was a similar debris flow that happened in Carpinteria. Fortunately, it didn't result in the loss of any property or lives, but it did have a pretty large impact on the marsh. Next slide. Large amounts of sediment and large woody debris were washed from the burned foothills above the marsh down into the marsh. And so on the left, there is a photograph of one of the marsh subtidal channels before the debris flow. And then the right is that exact same channel after the debris flow. And you can see it's completely full of sediment and debris. Next slide, please. Now, this obviously results in large amounts of habitat loss, disruptions to the marsh food web, and even the introduction of toxic compounds that came down with the debris from the watershed. Next slide. So we were faced with the decision of how we were going to monitor this and how we would sort of track how the marsh recovered, if indeed the marsh could recover. And fortunately, there's a lot of research that goes on in the Carpinteria Salt Marsh. And so we had a really good digital elevation map of the pre-debris flow conditions. And so this is an example of that DEM from November of 2017, which was just 2 months prior to the debris flow. And you can see we've got it scaled there for elevation in meters. So the darker colors are the deeper depths and the lighter colors are the higher elevations. Next slide. So we also were very fortunate in that one of our researchers had done a drone flight in November associated with constructing that digital elevation map. And I got him to fly another flight just a week after the debris flow. And so on the left there, you can see two photographs, two orthomosaics that were constructed pre on the top and post flow on the bottom. And then we were able to use some software to actually compare the point clouds and come up with changes in elevation. So the large color photo there on the right isn't actually elevation any longer. It's now changes in elevation. Areas shown in red represent areas that have increased in elevation, i.e. those areas that have been filled by the debris. And you can see almost the entire marsh, even areas that aren't in the channels, just the surface of the marsh, actually receive debris from the debris flow. Next slide. Now, what was fascinating to us was that we did actually see some partial recovery. These are two slides taken a year apart of two different channels in the marsh. The one on the left is the immediate post-debris photo, and the one on the right was taken 1 year later, actually in January of 2019. And so next slide. And so we were able to use the exact same technique by flying the drone again in January of 2019 to look at what had happened to that massive amount of debris. And what you can see is the areas shown in blue are areas now that have increased in depth between those two periods, between immediately after the debris flow and 1 year post debris flow. And that channel that I just showed you in the previous slide that sort of cleared of debris is that really nice dark blue line there on the right-hand slide running from top to bottom. Next slide. And that's really all I have. So this was just sort of an example of how we've been using drones to actually map reef resiliency and recovery post debris flow. Thank you.